There is a world orbiting Jupiter that is larger than the planet Mercury. It has its own magnetic field. It generates its own auroras. It has a molten iron core and a subsurface ocean deeper than anything on Earth. By every measurable definition that planetary scientists use, it qualifies as a planet. Except it will never be called one, because Jupiter owns it, and Jupiter is not letting go. This is Ganymede, the largest moon in the solar system, and it is trapped. Ganymede is 3,273 miles across. Mercury, the smallest planet in our solar system, is 3,032 miles in diameter. Ganymede is 241 miles wider. If you placed them side by side, Ganymede would dwarf it. If Ganymede orbited the Sun instead of Jupiter, astronomers would have classified it as a planet the moment telescopes were invented. But it does not orbit the Sun. It orbits Jupiter. And that single fact has locked it into a category it will never escape. The International Astronomical Union has 3 criteria for planethood. The object must orbit the Sun. It must be massive enough that its own gravity pulls it into a roughly spherical shape, and it must have cleared the neighborhood around its orbit of other debris. Ganymede meets 2 of those 3 requirements easily. It is spherical. It is gravitationally dominant in its immediate space. But it does not orbit the Sun. It orbits Jupiter. So it is a moon, not a planet. The rules are clear, and the rules do not care how big you are. What makes this particularly cruel is that Ganymede did not choose this. It formed in the early solar system the same way planets did, from the collapsing disk of gas and dust that surrounded the young Sun. In a different timeline, a slightly different configuration of orbital dynamics, Ganymede could have been flung outward into its own independent orbit. It would be the 9th planet, larger than Mercury, smaller than Mars, a rocky, icy world with its own magnetic field and a subsurface ocean, sitting somewhere in the outer solar system. But Jupiter's gravity captured it, pulled it into orbit, and Ganymede has been circling the gas giant for 4.5 billion years with no way out. Jupiter is not a gentle captor. Its mass is 318 times that of Earth. Its gravity well is so deep that anything caught in it stays caught, and its magnetic field is 20,000 times stronger than Earth's. It traps charged particles from the solar wind and accelerates them to near light speed, creating radiation belts that would kill an unshielded human in hours. Every moon orbiting Jupiter sits inside this radiation environment. For most moons, this is a death sentence. No atmosphere, no protection, just raw exposure to one of the most hostile environments in the solar system. Ganymede does something none of the other moons can do. It fights back. Ganymede has its own magnetic field, not borrowed, not induced, its own, generated deep inside the moon by a dynamo effect in its molten iron core. That core is still liquid, still convecting, still producing a magnetic field strong enough to carve out a protective bubble around the moon. A mini magnetosphere nested inside Jupiter's much larger one. It is the only moon in the entire solar system that does this. Europa does not have one. Titan does not have one. Our own moon does not have one. Only Ganymede. That magnetic field creates auroras, just like on Earth. When charged particles from Jupiter's magnetosphere collide with Ganymede's magnetic field, they spiral down toward the poles and crash into the thin atmosphere, exciting oxygen molecules and causing them to glow. In 2021, NASA's Juno spacecraft flew within 645 miles of Ganymede's surface and captured infrared images of those auroras. The structures looked almost identical to Earth's northern lights. Same physics, same eerie shimmer, same green glow flickering across the poles of a moon that, by all rights, should be dead. But the magnetic field is not protecting Ganymede. It is redirecting the damage. On Earth, our magnetic field shields the entire planet from solar radiation, deflecting it away into space. On Ganymede, the field is too weak to deflect Jupiter's radiation entirely. Instead, it funnels it. The field lines channel high-energy particles directly toward the poles, concentrating the bombardment at the exact locations where Ganymede's thin atmosphere exists. The auroras are not just beautiful, they are evidence of destruction. Every photon of light you see is a particle slamming into the surface, stripping away molecules, eroding the atmosphere faster than it can be replenished. The magnetic field that makes Ganymede unique is also slowly killing it. And beneath that magnetic chaos, beneath 100 miles of ice, there is an ocean. We know this because of how Ganymede's auroras move. In the 1990s, the Hubble Space Telescope observed them oscillating in sync with Jupiter's rotating magnetic field. That kind of movement only happens if there is a layer of electrically conductive material beneath the ice. Salt water. The Galileo spacecraft confirmed it by measuring Ganymede's induced magnetic field directly. The data was unambiguous. There is a global ocean beneath the ice, roughly 60 miles deep, sandwiched between an outer ice shell and a deeper layer of high-pressure ice below, 60 miles deep. That is 10 times deeper than the deepest point in Earth's oceans. Ganymede has more liquid water than our entire planet, and nobody can touch it, because the ice shell above it is over 100 miles thick in some places. That is not a barrier you drill through. That is a fortress. If there is life in Ganymede's ocean, it is buried so deep that we may never reach it. The ocean is there. We know it is there. We have measured it. But it might as well be on another planet. And here is where it gets worse. The ocean might be dead anyway. On Earth, life exists where water meets rock. At hydrothermal vents on the ocean floor, seawater seeps into cracks in the crust, gets heated by magma, and comes shooting back up, loaded with minerals and chemicals. Those vents are ecosystems. Europa has this. Enceladus has this. Their oceans are in direct contact with rocky mantles below. Water touches rock. Chemistry happens. Life becomes possible. Ganymede does not have this. Computer models suggest that the bottom of the ocean is not rock. It is ice. High-pressure ice that forms under the crushing weight of 60 miles of water above, dense enough to stay frozen even at temperatures above the normal freezing point. That layer of ice sits between the ocean and the rocky mantle, acting as a barrier. The ocean never touches the rock. There is no chemical exchange, no mineral cycling, no nutrient flow. The ocean exists. It is massive, it is liquid, but it may be chemically isolated, sterile. That makes Ganymede potentially the largest dead ocean in the solar system. A world that looks habitable from every angle, but cannot support life because of a technicality in its internal structure. All the ingredients are there, just arranged in exactly the wrong order. In 2031, the European Space Agency's JUICE mission will arrive at Jupiter, Jupiter Icy Moons Explorer. It will spend years studying Ganymede in unprecedented detail. Ice-penetrating radar will map the thickness of the ice shell. Magnetometers will measure the magnetic field. And most critically, JUICE will determine whether that high-pressure ice layer at the bottom of the ocean is real or just a prediction. If it exists, the conversation about Ganymede's habitability ends before it starts. If it does not, there is a narrow possibility that chemical exchange between the ocean and the rocky mantle could occur. Enough to allow nutrients into the water. Enough to create conditions where life could, in theory, begin. JUICE will tell us whether Ganymede is the largest habitable environment in the solar system, or the loneliest ocean in existence. Either way, Ganymede will keep orbiting. It does not care what we discover. It does not care that it is larger than Mercury, but will never be called a planet. It just exists. A world the size of a planet, with the features of a planet, doing everything a planet does, locked forever in orbit around something bigger. Ganymede is not a failed planet. It is a captured one. It has a molten core, a magnetic field, auroras, an ocean larger than all of Earth's oceans combined. It is doing everything right, but it is doing it in the wrong place. And the wrong place, in this case, is inside Jupiter's gravitational prison. It has been in captivity for longer than complex life has existed on Earth. It will stay there long after humans are gone. Long after the sun swallows the inner planets. Long after everything we have ever built has turned to dust. Ganymede will still be there, circling Jupiter, generating its magnetic field, sheltering its hidden ocean, pretending to be the planet it will never be allowed to become. The largest moon in the solar system, bigger than Mercury, locked in place forever.